Welcome to our EE3 project. My name is Jonathan Proctor.
My name is Kevin Deng.
And we have the switch activated door with the photodiode based trespassing alarm.
The goal of our project is to create a door with reasonable accessibility and security measures. The door's opening mechanism is password protected, for which the user must input a 4-button sequence matching the passcode stored within the system. The passcode is resettable by the user only by beginning the reset process, inputting the correct passcode, and then inputting the new desired passcode. In addition to a passcode, there is an alarm that is triggered when someone decides to go through the door. He or she will block a laser and cause an alarm to sound. The user interface consists of buttons and LED indicator lights of various events. An Arduino is used to program the logic of the system.
For the components, we have an Arduino, a stepper motor, laser, photodiode, switch buttons, LEDs, and resistors. The Arduino compiles and processes our code to make the stepper motor function. The stepper motor has a different configuration besides a servo motor. The laser is our tripwire for the alarm. The photodiode detects if light is being obstructed if an object passes the laser. 4 switch buttons process our passcode, and we have LED indicator lights to indicate the operations of our project. For the preparation of this project, we have to learn Arduino code. It's different from regular C++. There's different commands that we have to go through and figure out how they work. We had to learn about a stepper motor. It's distinctly different than a servo motor. We had to go to a website to see how the configuration works for that particular motor. And also we had to gather materials. We bought our materials from eBay, and it all came in one quick kit, the Arduino and all of the components. And to build the project, it took about 4 weeks, and it consisted of making the circuitry and also making the compartment for the garage and the pulley.
For the schematics, we have our user panel. We have 4 buttons for user input, 4 yellow LEDs signaling the press of their respective buttons, 2 blue reset LEDs signaling the stages of the reset process, ones where it's began and ones where the user has already inputted the correct password and now will input the new password, a red LED that represents the alarm, and a white LED representing the position of the door. For the trespassing alarm, we have a laser shining into a photoresistor. When an object or person comes in between them, the reduction of light hitting the photoresistor would be detected and the alarm LED would be turned on.
As Kevin stated on the previous slide, that's the schematic of our breadboard. This slide right here shows the true picture of our breadboard with the switch buttons, the indicator lights that were stated. This top picture shows the inside of our compartment of our garage door. We used 4 pennies to add weight to the door. That way it doesn't get stuck when going up and down through the slots of the garage compartment. And also we have the photoresistor on the left side and the laser on the right. And the bottom picture shows our final product of our garage compartment.
We had plenty of design obstacles that we overcame throughout the project. The major one was a general lack of documentation for code for the Arduino. Examples of basic operations, such as retrieving the value of an analog input, were almost non-existent, and it took us a very long time to figure out. There were quite a few mechanical issues with the system also. The first is that we had to make an improvised pulley system for the stepper motor, as the motor did not come with any useful accessories. The general physical layout of the system also took quite a while to figure out. Aspects like how to fix the motor to a surface took us quite a bit of time too. The materials we bought were also very poor quality, since we got them from dirt cheap off of eBay. We had faulty wires which were awful to debug, buttons with very short pins, and a breadboard very stubborn to wiring. We will be purchasing more quality supplies for future projects. For our future implementations, we will be adding features such as an IR sensor and remote control instead of buttons, and there's plenty more possibilities. Overall, we learned a significant amount throughout our time in EE3, and with this project, I would like to thank Dr. Briggs and the TAs for all their help and support. Thank you.